Hello, my dear students. I am Aditya Chakraborty, lecturer in electrical engineering of Sri Ramakrishna Institute of Science and Technology. Today, I am going to discuss about the third lecture of the classification of lightning arrestor. So now, the first one of today's lecture is the valve type arrestor. So valve type arresters incorporate non-linear resistor and are extensively used on the systems operating of high voltage. So in the valve type arrestor there must be some non-linear resistance are used, and it can be operating at a very high voltage. So the figure shows in the next slide the various part of the valve type arresters can be shown in the figure. It consists of two assemblies. Number one in the series spark gaps, and number two is the non-linear resistors disc in series. The non-linear elements are connected in series with the spark gaps. Both the assemblies are accommodated in tight porcelain container, and this porcelain is act as an insulating medium. Now the first one is the series spark gap. The spark gap is a multiple assembly consisting of a number of identical spark gaps in series. So there must be some identical means same type spark gaps are connected in series. Each gap consists of two electrodes with fixed gap spacing. So this each gap has two numbers of electrodes and with fixed gap spacing, and gap spacing is same. The voltage distribution across the gap is line raised by means of additional resistance element called the grading resistors across the gap. The spacing of the series gaps is such that it will withstand the normal circuit voltage. However, an over voltage will cause the gap to break down, causing the surge current to ground via the non-linear resistance. Now the next one is the non-linear resistor disc in series. The non-linear resistor discs are made of inorganic compounds such as thyrite or metrocil. These discs are connected in series. The nonlinear resistors have the property of offering a high resistance to current flow when normal system voltage is applied, but a low resistance to flow of high surge current. So when the resistance high, when the line is in the normal carrying the normal system voltage, or the line is healthy, but the low resistance path is produced when the huge amount of surge current is flowing through the line. In other words, the resistance of these non-linear elements decrease with the increase in current through them and vice versa. So when the current is increased, then the value of the resistance of the non-linear element is decreases, or vice versa. So that is the function of non-linear resistance. Now you can see the image of valve type arrestor. So that is actual image, and that is the equivalent circuit of valve type arrestor. So here you can see the port sealing housing. I have earlier discussed that the outer side is covered by the port sealing. So there is the port sealing housing. That is the current terminal. That is the spark gap. These are the spark gap and these are the identical gaps. Okay. And there is a non-linear resistor here made by inorganic compound like thyrite. Okay. So that is the actual constructional view of valve type arrestor, and that is the equivalent circuit. You can see here the line, that is the line which is to be protected, and that is the spark gaps, and the spark gaps are identical or same spark gaps and grading resistors, and the set of non-linear resistors which is connected in series, and that is the earthing. So that is the valve type arrestor image. Now the silicon carbide arrestor. A great number of silicon carbide arrestors are still in service. The silicon carbide arrestor has some unusual electrical characteristics. It has very high resistance to low voltage and very low resistance to high voltage. So it is when the voltage is high or when the over voltage protection is needed, then the resistance of the silicon carbide is increased. So when the resistance high, when the voltage is low, and when the surge voltage appears, then the resistance is very low. And when so that means high resistance in case of normal voltage and low resistance in case of the surge voltage or high voltage or over voltage. So that is the characteristics of silicon carbide arrestor, or you can say that is the electrical characteristics of silicon carbide arrestor. When a lightning strikes or a transient voltage occurs on the system, there is a sudden rise in voltage and current. In the silicon carbide resistance breaks down allowing the current to be conduct to the ground. After the surge has passed, the resistance of the silicon carbide blocks increases, allowing normal operation. So when the over voltage occurs, what will happen? The value of the voltage and current is suddenly raised, and when the value of the voltage is rise, so the silicon carbide resistance is reduced, and then it allows the current to be conducted to the ground through the earth. And after the surge has passed, the resistance of the silicon carbide is increases and the normal operating condition is achieved. The silicon carbide arrestor uses non-linear resistor made of bonded silicon carbide placed in series with gaps. It is just like the previous one, okay, or just like the valve type arrestor. So there must be non-linear resistance are used, which is made of bonded silicon carbide placed in series with gap. The function of the gap is to isolate the resistor from the normal steady-state system voltage. One major drawback is the gap requires elaborate design to ensure consistent spark cover level and positive clearing after surge passes. It should be recognized that over a period of operation that melted particles of copper might form, which could lead to a reduction of the breakdown voltage due to the pinpoint effect. Over a period of time, the arrestor gap will break down at small over voltage or even a normal operating voltage. Extreme care should be taken on arrestor that have failed, but the overpressure relief valve did not operate. So now the last one is the metal oxide arrestor. So here you can see the image of the metal oxide arrestor. That is the metal oxide arrestor. The MOV arrestor is the arrestor usually installed today. The metal oxide arrestor are without gaps, unlike the SiC arrestors. This gapless design eliminates the high seat associated with the arcing discharge. The MOV arrestor has two voltage rating, duty cycle and maximum continuous operating frequency. Maximum continuous operating voltage. Unlike the silicon carbide that just has the duty cycle rating, a metal oxide surge arrestor utilizing zinc oxide blocks provides the best performance. As surge voltage conduction starts and stop promptly as a precise voltage level, thereby improving the system protection. Failure is reduced as there is no air gap contamination possibility, but there is always small value of leakage current present at operating frequency. So that is the metal oxide arrestor. It is important for the metal oxide arrestor. It is important for the test personnel to be aware that when a metal oxide arrestor is disconnected from an energized line, a small amount of static charge can be retained by the arrestor. It is very dangerous. So, there must be a safety precaution needed. So, as a safety precaution, the tester should install a temporary ground to discharge any stored energy. So, there must be a temporarily earthing is provided to discharge the stored energy. If there is any stored energy or if there is any static charge is present, it must be discharged through the earth. Otherwise, the person who is operating the metal oxide arrestor may be shocked due to the this charge or the static charge which is retained by the arrestor. So that's all about the classification of different types of lightning arrestor. Okay, thank you.